touched only on a tiny amount of it. But the question which everyone likes to ask, and which Viking was in fact intended in part to try to answer, is the question of life on Mars. Did we find any life on Mars? Now, there were many speculations which we've talked about. For example, Percival Lowell's idea of great canals. Notice we did not see anything like a canal in any of these pictures. Then there are views of other people. For example, this artist's conception of what we might find. Certainly be extremely interesting if we found exotic life forms such as this animal in left foreground and strange cabbage-shaped Martian plants in background. We saw not a hint of anything like that. Here is another possibility that someone proposed. A creature not just large enough to see, but interested in us, in the Viking lander, and in this particular case looking straight at the cameras, which certainly would have gotten a lovely close-up of its eyeballs if there had been such a creature, but we saw nothing like it. Nor did we see any artifact, any sign of manufacture of intelligent Martians. Here is, in fact, an artifact right here in the center foreground, but it is not an artifact from Mars. It is a product manufactured on the planet Earth. It is, in fact, the glove that covered the sample arm before the sample arm was deployed or used. And nothing of Martian manufacture was found, not even a wrapper to a stick of chewing gum or anything like that. No hint of anything large enough to see that was alive. Now, what's the significance of that? Does it mean that life does not exist on Mars? It's certainly relevant to the question of life on Mars. Well, we landed only at 2 places on Mars chosen for their dullness. We cannot tell whether this is a typical place on Mars as far as biology, or whether it would be like landing in the midst of the Gobi Desert or the Antarctic ice cap, looking around, seeing no life, and saying, aha, the planet is uninhabited. For safety reasons, we had to go where it was dull. But if this is typical, if there are no large organisms on Mars, it hardly excludes the presence of small organisms, because the Earth, for example, had organisms big enough to see only for the last 500 or so million years. And yet there's been life on Earth for about 4,000 million years. For that period of time, the Earth was covered with microbes, but had no macrobes, no organisms big enough to see. So the negative results, which are very interesting and important, no organisms big enough to see on Mars, does not say anything about little microscopic organisms. Fortunately, Viking was designed to look for them also. The experiments are in some sense limited. They can only answer some questions, but they are a first attempt to approach this question. Now, the way these experiments work is that the sample arm goes into the Martian surface under guidance from the Earth and examined by the television cameras. Here is a sample arm. I'm holding it, but in the real case, it's the Viking lander which holds it, positions it, and then gives the go-ahead, and we dig up some Martian soil, and it is withdrawn back into the spacecraft, and they're sent through a variety of hoppers and sent to the 5 experiments, 3 microbiology and 2 chemistry, and leaving behind a kind of small trench or furrow in the Martian surface. Such trenches or furrows can be seen. If we look at the next picture, we can see here to the right a picture of the furrow, and off to the left we can see the Viking sample arm that has dug the hole. We are playing in the sand of another world. And here is a sequence at left where we see the sample arm touching the Martian surface, moving a rock away, because we were interested in looking underneath rocks, places which were not exposed to the ultraviolet sunlight on Mars. And then off to the right, we see the moved rock and the furrow adjacent to it, which was made when we grabbed the sample and withdrew it back into the spacecraft. Now, over here, I am going to try to describe two of the experiments designed to look for Martian microbes, little organisms, if they exist on Mars. We don't know if they could exist. You remember we talked about some experiments with Mars jars showing that terrestrial little bugs might be able to survive and grow on Mars. We talked about experiments on the origin of life in which the most common conditions early in the history of a planet seem to point towards the origin of life. Well, did that happen on Mars? Did life once originate on Mars? Did it evolve? Has it survived the changing climate of Mars? Could those microbes be in existence today? Well, I want to describe here, this is symbolic experiments. These are not the real experiments on Mars. We didn't have little eyedroppers and somebody to squeeze the eyedropper. But this indicates the basic point of these experiments. One experiment looked for the breathing, the respiration of Martian organisms. The idea was we brought to Mars food which we hoped the little Martians would love to eat, if there were any little Martians. Here, beneath this eyedropper, in this pipette, is some of that food. Below it is, imagine, Martian surface material which has been put there by the Viking sample arm. The food is radioactive. The Martian atmosphere is not radioactive. We drop the food onto the Martian surface. Now, if there are Martian microbes that love this food, they might oxidize it, as we do when we eat food, and give off carbon dioxide. That carbon dioxide would be radioactive. So if we found an increasing amount of radioactive carbon dioxide in the Martian atmosphere after giving food to the soil, we might deduce that there are microbes there. And so, in this experiment, we will want to put the active end of a Geiger counter into the atmosphere in here, and the increase in the rate of counting radioactivity indicates that there is radioactive carbon dioxide, only a little bit, but more than before, and therefore that some interesting chemistry, like respiration, has happened inside the chamber. There are always a few clicks, even when it's not close to radioactivity, because of cosmic rays coming in and striking the detector. Now, that's the story of this experiment. Here's, in a way, the opposite experiment. Here, the plants, I'll talk about in a second. We didn't have plants on Mars. They're just to help us understand. Here, we introduce radioactive carbon dioxide, C14 labeled carbon dioxide it's called, and see whether the Martian soil is able to capture, acquire, grab that carbon dioxide and convert it into organic matter. So here I am symbolically making carbon dioxide. Well, actually, I am making carbon dioxide by dropping sulfuric acid on some carbonate, and the frothing and bubbling that's going on there is the generation of carbon dioxide. Imagine now the radioactive carbon dioxide spreading out in the interior of this chamber, and the Martian soil acquiring that radioactive carbon dioxide, converting it to organic matter. That organic matter will be labeled with radioactivity. And so, if I can ask you to hold this without burning yourself with sulfuric acid, and take the Geiger counter. In this case, I'm going to put it on the leaf. And we see, sure enough, radioactivity has gotten into the leaf. That would prove, if this were on Mars, that the leaf was alive. Well, we know leaves are alive anyway. But if I put it down here on the soil, and imagine no plant there, then that